Assalamualaikum dear viewers, Shoaib Ahmed is here with another lecture of the electrical machines, and today we are going to discuss the self-excited DC generator. And in our previous lecture we have discussed the separately excited DC generator. Now the self-excited DC generator is that a DC generator whose field magnet winding is supplied the current from the output of the generator itself is called as the self-excited DC generator. And if we can differentiate the separately excited DC generator and the self-excited DC generator, a DC separately excited generator requires an independent DC source like battery to excite the field winding. But here in the self-excited DC generator, a DC generator whose field magnet winding is supplied the current from the output of the generator itself is called as the self-excited DC generator. So there are the three main or major types of the self-excited DC generator depending upon the manner in which the field winding and the armature winding is being connected. So the first is that the shunt wound generator, second is the series wound generator, and third one is the compound wound generator, in which there are the two types, the short shunt compound generator and the long shunt compound generator. Now how the self-excitation is achieved in the self-excited DC generator. So let us discuss some few points regarding the how self-excitation is achieved. Now if we recall the operation of the DC generator, if the generator is generated the voltage DC across the armature terminals, and there are the two main essential components of the DC generator, like main three components, field coils, the armature winding and the commutator. The field coils are produce the magnetic fields, or necessary MMF is to be produced or generated in the field coils, and when the armature is rotated with the help of the prime mover, and which the working EMF is produced. So according to the Faraday's law of electromagnetic induction, whenever a flux is linking with the coil is changes, an EMF is induced in the armature conductors, and in the armature winding always the EMF or the voltage is induced, which is the AC voltage, and we are going to connect an assembly with the same shaft of the armature, with the same shaft of the armature core, which is the commutator, which is the mechanical rectifier which converts the AC voltage into the DC voltage. So the when armature is rotated means when in the case of the DC generator, the armature is rotated with the help of the prime mover, and which the working EMF or the generated EMF is induced in the armature conductor or the windings. So a small voltage is induced in the armature winding due to the residual magnetic flux in the poles. Now the voltage produces a small field current in the field winding, causes the flux per pole to increase. So according to recall the EMF equation of the DC generator that I have derived in my previous video, you can see on my playlist of the DC generator. So that Eg is equal to phi n Zp over 60A. So the generated EMF, okay, is totally depend upon the number of the RPM and the flux per pole. If the flux per pole is going to be increased, the lines of the cuts of the flux are going to be increased. What happened? The generated EMF will be more. So the increased the flux induced voltage, the further increases the field current. So this takes place rapidly, and the generator builds up the rated voltage. So this is the how this self-excitation is being achieved in the case of the DC self-excited generator. So a DC self-excited generator, I am going to recall the definition of that. A DC self-excited generator is that whose field magnet winding is supplied for the current from the output of the generator itself is called as the self-excited DC generator. So in our today's lecture we are going to discuss the first self-excited DC generator, which is called as the shunt wound generator. The shunt wound generator, now we are going to discuss. Now the shunt wound generator is the type of the self-excited DC generator in which the field winding is connected in parallel across the armature winding, so that the terminal voltage of the generator is applied across it. So, first of all we need to draw the circuit diagram of the DC shunt wound generator, and then I will write this some few points regarding the circuit diagram. So, number first we are going to draw the circuit diagram of the DC shunt wound generator. So, as we know, there are the two main windings, the armature winding and the shunt field winding. So, this is the armature, okay, and this is the shunt field winding. Now, this is the load which is connected across the DC shunt wound generator. Now, these are the carbon brushes placed on the armature winding, armature core, and this is the positive brush, and then this is the negative brush. Now, this is the generated EMF which is produced in the armature. This is the current and the resistance of the armature. Now, the armature produces the armature current in the armature winding of the DC generator, and this current is divided into the two parts. The current which is towards the load side called as the IL, load current, and this armature current means the only a part of the armature current is flow through the shunt field winding, and rest of the current is flow through the load. So, this is the R shunt, this is the shunt resistance of the field winding, and this is the shunt field current, and this is the load current, okay, and so this is the, this is the field winding, okay, which is normally called as a shunt field winding, and this is the armature winding, and at the load side we are getting the terminal voltage. What? Terminal voltage. So, this is the circuit diagram of the DC shunt wound generator, in which the armature winding is connected in parallel across the shunt field winding, and the shunt field winding has so many turns of the fine wire having the high resistance, okay, to produce the desired amount of the MMF, and only a part of the armature current is flow through the shunt field winding, and the rest of the current is flow through the load. So, let's write down, I am going to write down some few points regarding the DC shunt wound generator. Now, first point is that in the shunt wound generator, okay, now in the shunt wound generator, the armature, this is the armature winding of generator is connected, okay, is connected in parallel across the field magnet winding, so that the terminal voltage, of generator, okay, applied across it. Now first point is that the field magnet winding is connected in parallel across the armature winding, so that the terminal voltage of the generator is applied across it. Number first point. The second point is that the shunt field winding, the shunt field magnet winding has so many strands of fine wire, has so many strands of the fine wire having high resistance, to produce desired amount of MMF. So here MMF means, if you are talking about the field magnet winding MMF, so MMF already MMF is the number of the turns of the wire and the, for example, the shunt field current. So MMF is the product of the number of the turns of the wire, like here if we are discuss the shunt field winding, so the shunt field winding number of the turns multiplied by the I shunt, so we can find out the desired amount of the MMF is going to be produced in the shunt field winding of the DC generator. Okay. Now number third point is that therefore only a part of armature, therefore only a part of this armature current, is flowing through the shunt field winding, and only a part of the armature current is flowing through the shunt field winding, and rest of the current is flowing towards the load, and rest of the current is flow through the load. So these are the some essential points or the important points which are related to the DC shunt wound generator. So now after that, write down some formulas related to the DC shunt wound generator, so that how we are going to find out the shunt field current, the armature current, the terminal voltage, the power developed in the armature, and the power delivered to the load. Number first is that if we are going to find out the shunt field current, so number first is that the shunt field current, if we are going to find out this I shunt in the case of this DC shunt wound generator, so I shunt will be equal to, according to Ohm's law, V over R. So this will be terminal voltage divided by the R shunt. So this is the formula for calculating the I shunt in the case of the DC shunt wound generator. Second one is that the armature current. Okay. Now as you can see, this armature current, okay, is the sum of this IL plus I shunt. So armature current of the DC shunt wound generator, so here this IA is equal to the, now this IA is equal to the IL plus I shunt. So this is the second point, that how we are going to find out the armature current in the case of the DC shunt wound generator. So it is the sum of the IL plus I shunt. Number third is that terminal voltage. So terminal voltage is the V. So V is equal to this, V is equal to Eg minus Ia Ra. Eg minus Ia Ra. So this is the generated EMF minus current produced in the armature conductors and the resistance of the armature. Number 4 is the power developed in armature. So the power developed in the armature is the power is the product of the VI. So here it is the product of the Eg, generated voltage, generated EMF in the armature conductors, multiply with the armature current. So this is the power developed in the armature. And number 5th formula, which is the power delivered to the load. So the power delivered to the load is the EGIA, power developed in the armature, minus power loss Ia square Ra. So here again, taking Ia as a common over here, so Ia is equal to Eg minus Ia Ra. So here power delivered to the load is the this is the EGIA is the terminal voltage. So VIA, okay, or that will be same as that the VIL. So power delivered to the load is the product of the load current multiplied by the terminal voltage. Let's solve the problem which is related to the DC shunt wound generator. So first of all, see the description of the problem. A DC shunt wound generator delivers the 450 ampere, which is the load current, okay, and 230 volt, and the resistance of the shunt field means RSH is the 50 ohm and your RA, resistance of the armature, is the 0.03 ohm respectively. Now calculate the generated EMF. We have to find out the generated EMF in the case of the DC shunt wound generator. So before going to solve this problem, first of all we need to draw the circuit diagram of the problem and also write down the data, and then we will solve the problem. We will move towards the solution of the problem. So first of all we need to draw the circuit diagram of the problem. Again this is a DC shunt wound generator. So shunt field winding is connected, this one is connected in parallel across the armature winding, and this is the load and this is the load. Like these are the carbon bushes placed on the armature winding. This here Eg is produced and Ia is produced, and here this is the R shunt, and this is here, this is the resistance of the armature, and this is the Ia, this is the IL over here, and this is the I shunt, and here the terminal voltage of the generator is applied across it. Now write down the data. Here the terminal voltage is the 230 volt, okay. The IL is the 450 ampere, the current, load current. The R shunt resistance, which is the here like 50 ohm, so this is the 50 ohm, and the resistance of the armature over here 0.03 ohm, and this is the 0.03 ohm. Now we have to calculate the Eg in the case of the shunt wound generator. So the main formula for calculating the Eg over here, that is the Eg is equal to V, now here same one here, the Eg is equal to V plus IA RA. Or how we are getting this? For example, the terminal voltage of the DC shunt mode generator is the EG minus IA RA. Now from here, if we are going to find out this EG, so this will be V plus IA RA. Now we have to find out the armature current, okay, and the armature voltage drop, and then we will put that value in this formula, then we will get the EG. Now first of all, we need to find out the shunt field current. So shunt field current is the ISH is equal to V over RSH. So V is the 230 volts, V is the 230 volts, okay, divided by, V is the 230 volt divided by RSH is the 50. So 230 divided by 50 is the 4.6 ampere is the shunt field current. So in the case of the DC shunt mode generator, the armature current is the sum of this IL plus ISH. So we can easily find out here the armature current. So IA is equal to IL plus I shunt. So what is the value of the IL over here? 450, okay, plus what is the value of I shunt? 4.6. So this will be 454.6 ampere is the armature current, okay, and this is the I shunt, okay, which is the 4.6 ampere. So we have calculated the armature current and the shunt field current. Now we can easily find out the armature voltage drop. So armature voltage drop is equal to the IA RA. So what is the value of the IA? 454.6 multiplied by the, what is the resistance of the armature, which is the 0.03. So 0.03 ohm. So we can multiply this 454.6 multiplied by 0.03. So this will be 13.63, okay, 13.63. So this is the armature voltage drop, okay, this is the armature voltage drop. Now we are going to find out now here the EG. EG is the V plus IA RA, V plus IA RA, okay. So now what is the value of the, this is the terminal voltage. So EG is the sum of the terminal voltage plus armature voltage drop. So what is the value of the terminal voltage? 230. And what is the value of the armature voltage drop? 13 point. So this will be 13.63, okay, plus 13.63. So this will be 243.63 volts, which is to be produced or developed in the armature, which is produced or developed in the armature conductors. So this is the armature voltage drop and its unit is volts, okay. So I forgot to write the unit over here, okay. So this was the problem related to the DC shunt mode generator. So that we have data and we have to find out the generated EMF in the case of the DC shunt mode generator. So formula for calculating the generated EMF in the DC shunt mode generator is the EG is equal to V plus IARA. First of all, we need to calculate the I shunt is equal to V over R shunt. So V over R shunt we have calculated the 4.6 ampere is the I shunt and IEA is the armature current, which is the sum of the IL plus I shunt. So we have calculated the 454.6, which is the IA. So again, after that we have calculated the armature voltage drop, which is the IARA. So that is the 13.63 volts. Now at the end, so generated EMF is the sum of the terminal voltage plus armature voltage drop. So that will be the 230 plus 13.63. So we have got the value of the generated EMF at the output of the generator is that 243.63 volt, which is to be this generated EMF is produced by the DC shunt wound generator. So this was the whole lecture regarding the self-excited DC generator, in which we have covered the self-excited DC generator. What is a self-excited DC generator? Those generators are a DC generator whose field magnet winding is supplied the current from the output of the generator itself is called as the self-excited DC generator. And there are the three main self-excited DC generators: the shunt wound generators, series wound generators, and the compound wound generators. And the how the self excitation is achieved we have covered in our today's lecture, and also we have covered the DC shunt wound generator operation, in which the DC shunt wound generator, the field winding is connected in parallel across the armature winding. So the whole terminal voltage of the generator is appear across it, and the shunt field winding has the so many number of the turns of the wire having the high resistance to produce the desired amount of the MMF and the armature. So therefore only a part of the armature current is flows through the shunt field winding, and rest of the current is flow through the load. So this was the whole lecture regarding the DC shunt wound generator operation. I hope that you have enjoyed the today's lecture, and this lecture is very informative for you all. I hope that, and at the last, please do subscribe my YouTube channel Shoaib Ahmed Dayo for more informative videos related to the electrical engineering area. Thank you.